Good morning, everyone, and thank you for having me here. This is a really great place. The hosts here at Red Hat took me out last night, and I already fell in love with the city. I'm German originally, and you have wonderful beer here and wonderful food. Awesome. I think it's always also a great place. I don't know if you remember your biology class in high school. Gregory Mendel actually did a lot of his research here in Brno, which is kind of one of the founding fathers for genetics and genetic, engineering even, because he did a very engineering-like approach on that side. Thank God I don't talk about this because it's not my area. I'm Mike Zink. I'm from the University of Massachusetts Amherst. For those of you who are in any of the Massachusetts offices, there is actually a western part of the state, west of I-95. Come out there and visit us. It's beautiful out there. And today, thank you for giving me the opportunity to talk about a new project that's an NSF-funded project, Open Cloud Testbed, where we're working on developing a testbed for the research community for next generation cloud platforms. And I want to give you, what I want to do in my talk is give you a little bit of an idea, give you background information, what we're building on. We're not just coming out of the blue, obviously, no one mostly does. Give you a little bit of background information, what we're building on and why this helps us to build what we're trying to build. And I'm not necessarily giving a research talk here, but what I want to do is inspire you and tell you what you're building, what we are building, so you can use it for your research. Our work is mainly for the systems community in the computer science and the computer engineering field, and building platforms so others can come and evaluate their work, their research at different scales. And I'll talk about this. I should mention this is collaborative work with Oran Krieger and Martin Herbert from Boston University, and Miriam Lisa and Peter Desnoyers from Northeastern University. So I work actually with people inside the 95 corridor. So what is MGH PCC? Anyone who knows what that is? Okay, a couple people, right, you guys know that. So this is the Massachusetts Green High Performance Compute Center. In 2012, a little miracle happened. 5 universities, Boston University, Northeastern University, Harvard, UMass, and MIT got together with the state of Massachusetts, and they built a research high-performance compute center. 15 megawatts, 90,000 square foot facility. Houses a lot of high-performance computers, some supercomputers. Every institution has their HPC equipment in there, which is important, but I want to talk about a couple other components in there. First of all, why is this? Holyoke is actually another town that's in western Massachusetts, pretty much in the middle of nowhere. If you're a history buff, you should read about this town because it was one of the first industrial plant cities in the United States. They built canals off the river. They did a lot of water power stuff for paper mills actually at the time. We're using this power now, we're using the water power now to generate electricity, and that's why it's a green high-performance compute center. The thing also is electricity out in that area of the state is much cheaper than in Cambridge or in Boston. So that's really good for those universities because they're paying a lot less for the power to run their computers. What we also have out there is actually nice connectivity, nice fiber connectivity. I don't want to go into much of geography here, but if you see where the fiber is and where the center is, we're really close by. Right? We just have to cross the river. And so you can get data in and out very easily, very fast. What's also important is it has become a point of attraction for the research community. What we have here, I see Heidi in the background. She worked for the Genie program office for many years at Raytheon BBN. We have a Genie node in that center. Genie has been a National Science Foundation initiative for future internet research at scale. So we have good connectivity also on the layer 2 side to perform research. The Massachusetts Open Cloud is in there, where Red Hat is actually a really, really strong and big partner. I'll talk about that in a moment. And sometime by the end of the year, we will also get a Fabric node in there. Fabric is a new program out of the National Science Foundation for another future next generation internet research platform. The idea is to build out nodes. They're all connected 100 gigabit with in-network computation and so on. So this is a center that has high-performance compute, good networking connectivity, and is already well connected to a lot of other research platforms in the United States and beyond. Massachusetts Open Cloud. So Oran, Krieger, and Peter, about 6-7 years ago, came up with this idea. We need a cloud that is available to the research community, right? Think of, when I showed you the MGH PCC, it serves 5 universities in the state of Massachusetts. Think of all the students, right? We have 30,000 students alone at our institution. If you think about it, there's a couple 100,000 students who could be actually customers for that, right? And so the vision statement was to create a self-sustaining, at-scale public cloud based on the open cloud exchange model, a marketplace for industry partners, as well as a place for researchers, industry, to innovate and expose innovation to users. Right, so it's building a cloud, but also having a close collaboration between industry and research. And that's actually kind of what we're here for today, right? And so the goals were to produce an at-scale, efficient production cloud for a broad set of applications, create and deploy the open cloud exchange model, and have this as a testbed for research, open source development, and companies. And this has been really taken off over the years by not only having the compute resources there, but also other things. You guys are aware of Harvard's Dataverse? It's a huge repository with all kinds of data sets. That is actually now hosted at the Massachusetts Open Cloud. They moved away from Amazon because it's just costing them too much to store their data there. It's really great for research because a lot of people, we see this recently that a lot of people from the social sciences, in our case, from the School of Nursing, use high-performance computing, use cloud computing for some of their research, right? Data-driven, data science, big topics, and they can actually go and have these data sets right next door and can run this, and that makes it really efficient for their evaluation and for their work, right? So we have a data center, we have this open cloud that is available to the research community, to the open source community. There's an OpenStack Foundation is heavily involved, and to industry, Red Hat and other partners involved there. And then, so I come from a different project originally, and that is called CloudLab. So lots of clouds this morning, although the sun is shining out there, right? But that is another NSF, National Science Foundation project that came into existence about 5-6 years ago, and there it was driven by the thought, there's clouds everywhere, right? There's Amazon, there's all the public clouds, Amazon, Microsoft, IBM, what's the other one? Google, sorry. And a bunch of others, sorry, sorry if I leave any Europeans out, it's not on purpose. But we don't have really this open infrastructure for cloud research, right? So with the folks led by Rob Ritchie out of Utah, the folks who did EmuLab, and then also one of the Genie testbeds in the years before, we built a cloud research testbed. What's a cloud research testbed? It's a testbed that gives you bare metal nodes in an as isolated fashion as possible, so you can run your own cloud on this. Meaning your own cloud means you can actually run your own cloud operating system, your own cloud system on it. Any grad students here? I met one grad student already. There must be a bunch of grad students in here, right? If you come up with this wonderful, great idea and say, well, OpenStack, I can do this much better. You can try it out here because it's bare metal. You can bring up what you want, and you can dump it at the end of the day if it doesn't work. Which, when I was a grad student, that's how most days went, unfortunately. So what is CloudLab? It's a combination of 3 clusters at the University of Utah, Wisconsin, and Clemson. And we designed it, I think it's actually a couple more nodes by now, but at the time it was 15,000 cores. And we made it a little bit heterogeneous, so you have different strengths, so to speak, at the different locations. Utah, for example, has a bunch of low-power HP systems with ARM processors. We have lots of specific networking and high storage at Wisconsin, and high memory computing, for example, down in Clemson. Really important, and we had already discussion about this last night, quite a bit of work on reproducibility, right? This is something that's important, and I really would like to have some conversations during the day with the folks in the research community, because computer science and computer engineering hasn't been good at this, of how can we make our results available to the research community and repeatable by the research community, right? And that's one of the goals that we had in mind when we built CloudLab. And then hard isolation, so you can build many parallel slices, so this infrastructure cannot be used by one researcher also, but it can be used by a bunch of researchers in parallel, right? That's where you make things efficient. And the good news is we've been working really hard with the CloudLab folks, and through that Open Cloud Testbed grant we got from NSF, we actually have a location now also up and running in the MGH PCC, that high-performance compute center I showed you. Right? So this is all the stuff we have in place. And so now, why building another Open Cloud Testbed, right? And I'll be done in 10 minutes. So, first of all, cloud computing plays a very important role, right? Everyone uses clouds these days, right? I'm preaching to the choir. I don't have to tell you that. We use that in our daily life. But we need platforms to be able to do research, right? And the systems community, we do research by implementing things, by testing things, by evaluating things, right? That's another important stuff. And what we've seen over time, you can look. There's an ATC paper from last year with our analysis. Is the Cloud Testbeds? There's CloudLab, and there's actually another parallel project, Chameleon. They get overbooked, especially ahead of paper deadlines, right? And so, probably not new to you, but it's bad for the research community, really bad for grad students who want to get their paper out. Shoot, I don't get the resources to run my experiment, right? So that's a dilemma. But there's a bunch of compute around, and I'll show you in a moment how we want to use that. The other thing is, computer science and computer scientists and computer engineers, especially in the systems area, want to study users, right? That are not from CISE. We want to make sure the new bells and whistles we put in place in operating systems, in cloud stacks, and so on, really are to benefit. What you see most of the days, and I can tell you from my own research, is, well, we make up cases, right? We create synthetic data, we create synthetic payloads and all this stuff, but not actual data. With Massachusetts Open Cloud, right, the cool thing is we bring in real users. We have access to real data sets. I just talked about Dataverse and others. We can provide traces of actual usage, right? So there's a good telemetry, good measurements we have in there. And we can actually allow that we expose special services to end users. So it's kind of that transfer into practice, right, going on. Have access to certain production services. I'd be happy to talk to you a little bit more about this online. I don't have the time to go into all this during my talk here. And then we can actually, as has been happening already, for example, with Red Hat, work together with industry, see what industry can provide on one side, but also what we can feed back to industry to have this wonderful collaboration going back and forth and things. And then CloudLab, which I just talked 2 slides ago, brings a huge user base from the systems research community into that, brings a lot of tools to configure. Like I talked about, how do I set up my own slice, right? How do I get a bunch of bare metal machines? How do I connect them, network them together in an isolated fashion? How do I make my experiments reproducible? So we're bringing all these tools in from the CloudLab side with the hard isolation. We have something called profiles. So if someone creates a certain slice with a certain set of resources, you can actually make that public and someone else can use it. It helps with reproducibility, but it also helps so others don't really have to start from scratch. Often what we have seen is there's a lot of versions of these profiles where someone takes it. There's an OpenStack that's very popular, for example, right? You can just set up an OpenStack cluster on CloudLab. And then people take it and make their own modifications, add more nodes and so on. And so you don't really have to start from scratch. It's been something that's been really helpful. The software stack is open source. And you have the federation with some of the other test beds I just mentioned in my very early slides. So the Open Cloud Testbed is now this next step in terms of creating a testbed for research and experimentation into new cloud platforms. We want to combine the proven software that is available on the MOC and in Open Cloud. And then bring that into a real production cloud and enhance it with programmable hardware. We have, when we did an evaluation before we wrote the proposal for our project, sometime last year I would say, we figured out that in the research community there's some interest also in having access to FPGAs. Right? Now you're saying, well, you can get FPGAs at Amazon, at Microsoft Azure. Yes, you can, but you cannot get them in a completely open way. Right? Here, we make them available as bare metal, so to speak. Everyone has complete access to them, can use them for compute, can use them for what's called bump in the wire, right? If you're a networking researcher, you can run things like P4 on it, for example. and do your work there. And then the goal is to have about 30 nodes in place for that over the well, 50 nodes over the summer, and then another 50 nodes later on. We are actually in the process of evaluating different offers from different vendors. If you're interested, I'll be happy to talk to you about this online. I'll also be really interested in having trying to get feedback from folks who are already using FPGAs and your experience with those FPGAs. That would be I would be really interested in having a discussion. Little animation here. I know it's early in the morning, so I want to show a little bit. So what you see here is actually the CloudLab infrastructure we have in place right now with the three main clusters, the UMass or the mass cluster that's coming online at MGH PCC. The green circle here shows in resources at the Massachusetts Green High Performance Compute Center with the MOC. There's a huge storage project going on, and then all the institutional HPC clusters. And so what basically, one of the basic pillars of our future, of this work in Open Cloud Testbed is that, there's the CloudLab users that can use all the existing resources, but should there be a demand for more resources and should there be available resources, you can actually make resources from the MOC, for example, available in the CloudLab cluster. And so you have more research compute resources as bare metal nodes available. Long term, we're working with folks from Harvard and BU that we can also use some of the institutional HPC clusters. You run your experiment, you reserve these resources for a certain amount of time. Once that reservation expires, you can then, whoopsie, that went a little bit too fast. You can then actually release these resources and they can go back into the HPC. There's a couple of things that are necessary for that, and I'll come to this in a moment. So what's new, I already spoke to this very briefly, is the FPGAs, right? From what we know, there is definitely no FPGAs for actually in the network path available in Research Cloud at the moment. The Chameleon project has some FPGAs for computing, so we're adding them for computing and networking. So that's going to be a very exciting adventure, and we'll see how this turns out. Just a little graph of how we envision the plumbing, so to speak, in the architecture. Gives you a lot of interesting opportunities to do things here. Dynamically scalable. Here we work with ESI, Elastic Scale Secure Infrastructure. Some of you at Red Hat work on that also in parallel or in collaboration with the folks at BU. That is a way of safely moving bare metal nodes between different test beds, right? So scrubbing your machine because you might have been running in the MOC with some delicate data on it. If you want to move it over to CloudLab, you want to make sure there's nothing on there anymore that has compromisable information on it. So we're using that. And then we can actually coming back and transfer cloud mechanisms back into a production cloud. So in OCT, you can try out your new cloud mechanisms, your new OpenStack++, whatever, and then you can actually bring it back in MOC and have actual users working on that. And then access to storage data sets and so on. Collaboration with industry. I'm here at Red Hat today. We just got 180 nodes from 2 Sigma as a donation to expand our cluster. That was very nice. And then with that, we can actually make OCT available to not only the research community, but also to our partners from the open source community and from industry, because that's stuff that's not necessarily coming in from NSF. Okay, so we got some new hardware. With respect to time, I don't want to talk too much of detail about this. So nice, right before Christmas, it gets scary when the pile of servers you get is taller than you. I'm not that tall, I agree, but still, and we have it all racked up by now. We need to do a little bit more work. It's on the production floor, and hopefully we will have a lot more compute resources available very soon. Just want to show you the core team a little bit. David Irwin, also from UMass, is going to be responsible for outreach activities. Emmanuel is one of our software engineers here. Oran and Peter, my good friends from BU and Northeastern. Miriam, also from Northeastern. Martin from BU, and Michael Datesman, one of the champions at Massachusetts Open Cloud, who is doing a lot of the work and the coordination there. I want to wrap up my call with thanking, actually, the National Science Foundation for trusting in us and giving us more research funding for doing the work. I want to thank you and Heidi for inviting me to come out to the research day here. I'm really looking forward to all the interesting. I went through the program. There's a lot of interesting talks. I'm really excited about that. I want to thank Two Sigma for all the hardware we recently got. And I also want to thank the Massachusetts Green High Performance Compute Center, John Goodhue and Jim down there who like are really helpful with running operations, with getting new hardware installed and so on. If I have 1 more minute? Okay, awesome. Because what I want to say is like, there's never a dull moment. The next workshop's coming up pretty soon. Open Cloud workshop happening March, this is too small, March 2nd and 3rd at Boston University. This was the former MOC workshop, now with a lot of new things happening like OCT. We're having a hopefully super interesting workshop. There's involvement from Red Hat. There's involvement from the OpenStack Foundation. There's other industry partners going to be there. If you're local or if you ever want to go out to the wonderful city of Boston, come over March 2nd and 3rd. If you search for Open Cloud Workshop and MOC, you'll find actually the link for registration and so on. It's a 2-day program, lots of stuff happening there, workshops, a lot of interesting information. We would love to see you out there. Thank you very much, and I'd be happy to take any questions from you now.
Thank you. Okay, do we have any questions?
Will the FPGAs be programmed with your open source software?
No. I think the way, I'm not the FPGA expert. Martin and Miriam are the FPGA folks in the project. But from what I know at the moment is all the vendors come with specific tool chains, right?
We're trying actually to have the entire toolchain freely available. So we're actually working on that. So whether on day one, when we are going with one of the big vendors, we will have that available. I don't think so, but the goal is to have it all freely available. And we have this for some of the ones. So yeah, so in one of the research quarterly, so the one from November last year and so on. So Ahmed, he's now working for me.
Yeah.
Well, he's working for
He's Martin's student, right?
Pardon me?
He's Martin's student, right?
Yeah, well, he was. He was my PhD student,
yeah.
so he finished this year and so on. So he's working actively on these kind of things. So, so if you have questions about FPGA, so don't want to put Michael in the corner there. So, but you can talk to me about that part. So.
Yeah, no, absolutely. No problem at all. But the point is, we will probably so to get started, we will go with the tool chains by the vendors before we get to the point where we have solutions that we can put in place and make it available to the research community.
So thank you very much. My question is regarding the cryptographic hardware and support for that. Do you have trusted platform modules inside the hardware available, so I can try to run some cloud that allows me to do the attestation of the instances that are running there? In Boston, they are developing the Keylime that is using trusted platform modules. So is there any support for that?
Not specifically that project, right? But I know that there's a lot of collaboration going on with folks from the MOC with different industry partners. What you can do is actually since it's bare metal provisioning, you can run any kind of trusted, not hardware, but on the software side you can run it. I mean, on the hardware side, it is really you're limited to what we have in there, right? If you need a special chipset or something like that, then that's hard to achieve because we would have to bring that in.
So I need to figure out what you have there already.
Yeah.
Thank you very much.
Any other question? Okay, then thank you again.
Thank you very much.